All right, everybody, this is day 2 for 7-1. Going to go through a few more examples. The first example I'm going to do is this one, and I think in my day 1 video it was the last example that I did, but I know I didn't get all the way through all of them in all the classes, so I'll just repeat this one. So if you've already seen this one, you already have the work or you understand it, go ahead and just go to the next example. You can fast forward. Okay, so we have our list of strategies in our toolbox here that we talked about in day 1 about things it means to simplify. So I'm just going to jot down a couple of those again. So do order of operations, like do operations in there. See if there's anything that you can put together. So that was a strategy that we talked about. We talked about factoring. Is there a GCF that you can pull out? Can we do things into binomials? Or do we need to instead distribute because we have parentheses, things like that? I would kind of include that as part of order of operations, but kind of name that as a strategy. We talked about substitution. So substitute, put in, replace. We have that whole list of different identities we can use. And as part of that, you could change everything into sine and cosine. So using those functions, because every trig ratio can be replaced or substituted using sine and cosine, and see if you can then do those operations. So I think it's really key to realize that sometimes you use multiple strategies in the same problem. Sometimes we use the same strategy more than one time. So we actually get to go through and do what we need to do. So make sure that you think about that as your options. This is not like I only can do one of these. You can do lots of them, and sometimes we have to cycle back and use them multiple times. All right, so let's take a look at this one then. So I have 3 different terms there. I see a cosecant, a cosine, and a cotangent. So there are definitely not like terms. Oh, that's the other one. Shoot, I forgot that. Glad I just said that. So another one is like terms. And that would be, again, kind of part of order of operations. So can I put things together? All right, so I don't have any of those. I can't do the operation because I can't subtract them. Let's take a look at our other choices. Can you factor? Well, is there a GCF? Well, no, because none of those are the same. Can I distribute? No, there's no parentheses. So I must be looking at a substitution situation. So what kinds of substitutions could I make? In this case, there are no squares on anything. So the Pythagorean ones are out of it. So I think I'm down to, let's change everything into sine and cosine and see what happens. So first one, 1 over sine. Then I have cosine over 1. I'm going to write everything as a ratio. I think it's easier to try to keep track of those numerator and denominators. And then cotangent, that's cosine over sine. So everything is in terms of sine and cosine. Now, oh my goodness, somebody slammed the door next door here. So what you're going to get to in a situation like this, and once you've substituted, you've changed everything into sine and cosine, you're going to come to the kind of the realization that, oh, I don't know what to do next. I'm going to get stuck. And that's super common. It happens to a lot of people. So when I look at this, what can I do? I'm going to fall back on this always. See if you can do any operations. So in order of operations, I see a subtraction and I see a multiplication. So do order of operations. Let's multiply, because you'd multiply before you subtract. So cosine times cosine. So cosine of the first times cosine of the first would be cosine squared. Sine times 1 would be sine of x. And we've at least accomplished one operation. That's great. Now we need to subtract. All right, well, this is going to happen a lot because we have fractions. We have trig ratios. So when we look at these, we are subtracting. We need a common denominator. So I have one, thank goodness. If I didn't, I'd have to get one. Let's combine it and put it into a single fraction. So I would have 1 over sine together with cosine squared over sine would be 1 minus cosine squared over sine. So I know I can't actually put them together. They're not like terms, but I can write them as a single fraction. Okay, now the age-old question, are we done? Are we done yet? It's kind of like, are we there yet on the road trip, right? Are we done yet? Is there anything, other substitutions we could make that would make this better? And what do I mean by better? Fewer operations and fewer functions. If I can get it down to just single operations or single functions, that's better. Right now, I still have subtract and divide, and I still have cosine and sine. So look on your pink sheets, on your formula sheets here, your identities, and see if you have anything for that. 1 minus cosine squared. Anytime I see a squared thing, I start thinking, I wonder if there's anything in that Pythagorean list. And I think there is for this one. That's sine squared of x. And is that helpful? Okay, so what would be the argument for it being helpful? Well, now I don't have a subtraction anymore. I just have a single function, sine, and that single function happens to be the same that was in the denominator, so I'm going to be able to simplify. Even if I couldn't reduce it, it would still be better because I only have one function, so that's a better option. So sine squared over sine is just like saying y squared over y. I can take out a factor of sine, and I'm left with sine of x. So it's a really great example to show we can use, kind of cycle back to the same strategies again and again, that substitution, doing operations to solve. Okay, we're going to do two more here quick to finish up our day 2. So this one, let's take a peek. Think about our list. I know it's on the other slide, but you can just look back to it. Think about our list. Everything's already in sine and cosine, so I don't really need that strategy. They're not like terms, so I can't just do the operation. I don't see any parentheses, so I can't distribute. But let's take a look at the factoring. Can I factor it? And if you look in each of them, I see a factor of cosine, so I can pull out a cosine of x. So what's left inside then would be 1 minus sine squared. Now, have to take a look and see, can I do more? Now inside, 1 minus sine squared is a difference of squares. So theoretically, you could factor it further. This is exactly 1, just like our algebra warm-ups that we did yesterday. But instead, when I see squared things, I think a better approach might be, oh, is there anything I can replace that with? Can I make a substitution now that might make this better? And what is 1 minus sine squared? Well, that's cosine squared. Now my question is this, is that better? Does that make your expression easier to work with? Well, argument for that would be, yeah, because I only have cosines now. So I only have a single function, and I probably now can do more operations. So cosine to the first times cosine to the second is just like saying x to the first times x to the second. That would give you x to the third. So this would be cosine to the third. So I would consider that a more simplified answer. That would be an identity. Those are always true. So the graph of cosine to the third would be the same as that original. So we can have powers bigger than 2. All right, let's take a look at one more example. So from our list of choices, think through your options. Can I do those operations? Well, no, they're not like terms. Are there things to factor? No, because I don't have any common factors and I can't break them down into binomials. Let's see, what else do we have? Could we make a substitution? Now, one thing that people really want to do on this one, they see secant minus tangent, and they look on their pink sheet and they see this one, and they think that they can do that substitution because they just think, oh, if I can just take the square root on each side, then it would be secant minus tangent. But it isn't, because there's a subtraction sign in there. So it's not the same. So if you don't have squares, you cannot do that substitution. So we can't just put in a 1 down there. That's not the same thing. So we can't use a Pythagorean substitution. It's not squared. Okay, so then the next kind of logical argument from that is people say, okay, well, can I just square this ratio, top and bottom? And well, sure, you could. But remember, when you square secant minus tangent, that means you have to do secant times minus tangent times itself. And when you distribute, you're going to get more terms than just that secant squared minus tangent squared. That's not what that bottom would be equal to. So you probably can do that, and I bet you could get to that solution, and we'd probably end up with the same answer. But I'm thinking it might take us a lot longer than if we just fall back on our regular substitutions, kind of don't really know where to start, so change everything into sine and cosine. So secant is 1 over cosine, tangent is sine over cosine, and this might be a faster way to be able to deal with this. All right, so everything's in sine and cosine. A lot of people get to here and say, what do I do? Well, we have to do the operation. So we need to subtract in the denominator there. So I'm going to subtract those two fractions. Thankfully, they already have a common denominator. And in my numerator, don't really have to do anything. I guess I'll just write it as a fraction. All right, now, fraction divided by a fraction. Multiply by the reciprocal, so cosine over 1, that's the numerator fraction, times the reciprocal, so cosine over 1 minus sine. So we're just doing the operations. We're just doing what it asks us to do. So we multiply the fractions, numerator with numerator, so cosine squared over 1 minus sine. All right, so now we've pretty much done the operations, can't really subtract on the bottom. So now the question is, are we done yet? Is there anything else we can do? So let's think that through. If there's any other substitution or operation I could do that would make it better, we should try to do that. So I can't really substitute on the bottom. 1 minus sine isn't anything because it's not squared. But in the numerator, how about cosine squared? Whenever I see a squared, again, I kind of think, oh, is there something on the sheet I could use? Is there an identity that has to do with that? And what is cosine squared? Well, that's 1 minus sine squared. So I'm going to put this down as an option. Do you think that that makes it better? And by better, I mean fewer operations and fewer functions. Well, it looks like I have more operations, but now everything's only in sine. And my inclination might be then, maybe I can do something with that. So if you look back to the very first algebra warm-up question we did yesterday, it was this. And we talked about how we might be able to simplify that. 1 minus y squared, that's a difference of squares, so I can actually factor that. So this maybe won't even help you, but we need to check. So this is all about looking at all the different options and seeing what might make it better. And sometimes we start with something that doesn't work and we have to redirect. Sometimes it doesn't help at all. But sometimes, just sometimes, it does. Take a look. Once you factor your difference of squares, we now have a common binomial factor, and we can get this all the way down to 1 plus sine of theta. Now, are we done? Can you make any substitutions? The only thing you could put in would be 1 over cosecant for sine. Not better, because then we have a fraction. So 1 plus sine, I know they aren't like terms, is the most simplified that that expression can get. So we've gotten it all the way down to that relationship. So just kind of my disclaimer here as we wrap up. You can get frustrated with these. It's definitely a situation where you try some things or you get stuck. I don't know where to go. I don't know what I'm doing. Yeah, that happens, and it happens a lot. But that's part of like real life problem solving. We are faced with a problem and we have to come up with strategies that we can try, and we just kind of keep powering through. So a little frustration and a little bit of stick with it is what we need to do to kind of grow with these and make it a little bit more mathematical thinking for us. So try to power through the frustration, because there's lots of different ways to do these, lots of approaches, and we just keep trying until we find something that makes sense for us. All right, so our day 2, we're going to do a little bit from the book and then this puzzle sheet. So we'll talk about that and work through those. And good luck on your simplifying. I think once you figure them out, you're really going to enjoy this.